Hello, and welcome to Logarithmic Functions. This is going to be an intermediate algebra approach, so it's really kind of the introduction to logarithmic functions. So first of all, y equals log base b of x is the power to which you raise b in order to get x. That's it. This logarithm thing is just an exponent. So it's the power to which you raise b. So here we have b. I want to get x. The power I raise that to is log base b of x. Right, so this is all it is an exponent. That's it. And in fact, I state that right here in fact. Y equals log base b of x is the same as b to the y equals x, right? Log base b of x equals y. So b to the y equals x. Really, all a logarithm is an exponent. So everything we know about exponents, we also know about logarithms. If you remember that key fact, logarithms are a lot easier to deal with. Now, the base most commonly used is base 10. And it's called the common logarithm because it's commonly used, common logarithm. It's because most of us have 10 fingers, 10 toes. We have a base 10 counting system. It's just 10 is our current natural human base. It's used so frequently that we don't even write a b value. So if I have log base 10 of x, what I'll actually do is just write it as log of x. Anytime there's no base written, it's assumed to be 10. But in the sciences, the most natural base to use is a base of e, and this is called the natural logarithm. The 2.78, we talked about this in an earlier lecture. Check out the playlist if you need to see others. As it's so special to the sciences, it has a special notation. So this log base e is ln of x, and I just creamed that e, sorry about that. These are logarithms. Logarithms, they are not I, all right? It's just not I. The word logarithm starts with an L. YLN, if it's logarithm or a natural logarithm, as we call it here. The Latin, Logarithmic Naturalis. Logarithmic Naturalis. So make sure that's an L. Definitely an L. I get irrationally upset when people write I's for logarithms. Totally irrational, but still. Okay, so the way that this log base 3 of 9 translates is what power do I put on 3 to get 9? And of course, we know that that answer is 2. Because 3 squared equals 9. So all I'm looking for is the log is the same as the power. It's just an exponent. All right, so what power? That's what the log says. Do I put on 10? Because there's no base written. To get 10,000. Well, the nice thing about multiples of 10 is we can count the number of zeros. 1, 2, 3, 4. That tells me the exponent that I put on 10 in order to get 10,000. All right, let's try another one. We're actually going to try 2 more. What power do I put on 5 to get 125? We don't want to have to write the words all the time. So we want to start translating these into mathematical sentences rather than English sentences. Well, in this case, that power must be 3 because, yeah, I can spell because. 5 to the third equals 125. All right, so what power? When it's asking for a logarithm, all I want to know is what power. And when it comes right down to it, what power do I put on 2 in order to get 16? I put on the power of 4 because I'll use some shortcuts here. It is video after all. 2 to the 4th equals 16. All right, so the logarithm is 4 because the power is 4 that I put on 2 in order to get 16. 2 times 2 is 4. 4 times 2 is 8. And times another 2 is 16. So I use 4 times. All right, that's it. When it gets harder down the road, just remember, all a logarithm is an exponent. So let's look at some of these properties of logarithms. First property, the logarithm of 1 for any base will always equal 0. So log base b of 1 is always 0 because as long as b is not 0, b to the 0 power equals 1. The logarithm of its base is always equal to 1. All right, think about it. What power do I put on b to get b? Well, that power is 1 because b to the first power is b. That's it. All I'm doing is exponents. All right, now I just noticed how these notes are spelled wrong. My editor is slacking. Sucks, I'm the editor. All right. The logarithm of this base to a power, what? The logarithm of the base to a power is just that power, and that is super confusing. So let's see what I mean. So I'm asking, what power or what exponent do I put on b to get b to the m power? Well, it's the m power. M is the power that I put on b to get b to the m. All right, so these three properties, these are what I call duh properties, and that's really rude. They're like Jeopardy's stupid answers, right? They're so straightforward and no tricks whatsoever that it makes them hard. All right, so make sure you remember these first three properties. We'll have three more coming up soon. Since we'll call these the basic three. Basic three properties of logarithms. Since any base b is possible for b greater than 0, we can't have the base b of logarithm here on our we can't have all those different buttons for them. We can use a change of base formula in order to evaluate a logarithm. I want to show you real quickly. If you are using a graphing calculator, you could go to the math menu, and I'm going to scroll up. Not all calculators allow you to scroll up, but this one does. If I go to log base, if your calculator doesn't allow you to scroll up, just scroll down. Notice it allows you to put in, let's take the one from the top of the page, log base 2 of 16 is 4. So we could verify our result, but we don't need it for that. We know the power that we put on 2 to get 16. We don't need a calculator. But there's some times that we do need a calculator, and we could use this change of base formula. In the change of base formula, we have log base b of a, and we can change it to any base we want. The bases that we use most frequently are base 10 because of our calculator. It has a log button. That log button is base 10, and if you ever forget, notice in blue there's a little 10 to the power of, that's its inverse. Here is ln. It's obviously a capital L, capital N. That's the natural log. That was our special one, the base E. So it's in blue over here as a reminder. So in particular, I can rewrite log base b of a as the natural log of b. See how that b is already lower? That b is already lower, so it goes down below. Whereas the a is on the same line, so that's going to go up high. So I could call it log of a over log of b. I could call it log base 17 of a over log base 17 of b. Maybe 17 for some strange reason is my favorite number. I could also use natural logs, but make sure the base is always in the denominator. Let's do some examples of this type. Evaluate the following logarithms. Round your answers to 3 decimal places. Now I could come here to math and scroll to my log base and use my fancy version here, log base 3 of 470, and get 5.600. So we know our answer. All right, and it says round to 3 decimal places, so I'm going to put those 2 zeros there. But notice in my calculator, if I do log of 470 divided by log of 3, so let's do log of 470. Notice how the opening parentheses are already prompted for me. I have to remember to close them. Divided by the log of 3, close the parentheses. same exact answer. And it's even better than that. What if I chose to use the natural log instead of the common log? It doesn't matter. I could use a natural log of 470. Divide that by the natural log of 3. And I get the exact same answer. All right, that's fantastic. So the change of base formula allows us to use any base. And for that reason, this natural log form is usually on my go-to. The reason for that is I use a TI-89 frequently, and it does not have a log button. You have to type in L, O, and G, but it does have a natural log button. Also, the epitome of laziness, log has 3 letters, natural log has 2. That's quicker to write. I'd rather write 2 of them. All right, so I'm not going to use our fancy log base button because I have to go to a menu and scroll and do this and do that. Sometimes it's just easier. Natural log of, let's do it in the right order. Natural log of 3.2, close the parentheses, and then divide by the natural log of the base, close that parenthesis. Closing of parentheses, very, very important. All right, so I'm going to write this as the natural log of 3.2 over the natural log of 7. When I write it, I don't always use parentheses, as I probably should, but in my calculator, absolutely I put parentheses around all of it. 0.59, our 7 gets rounded up to an 8, 3 decimal places. Look at that, random 17 popping up here. I'm going to do log of 11. Make that an 11. And divide that by the log of 17. And we have 0.84, and that 6 will stay as 6. Now, make sure you hit pause. Work on your calculator. Make sure you can get these exact same answers. All right, a little bit of evaluation. Now let's do some rewriting into the opposite form. Here we have an exponential equation. Okay, these are the words I use to translate these. Translate? No, rewrite. 5 is the power that I put on 6 in order to get 7,776. So the words are 5 is the power, or exponent if you prefer. I put on 6 to get 776. All right, so that's exactly how it translates. What does this say? This says if the log is 4, 4 is the power that I put on 7 in order to get 2401. Okay, so I'm a mathematician. I've had a thing with numbers forever, like forever. And 2401 happens to be my childhood phone number. I don't know who has this number now, and please don't call it. That's my disclaimer, 208-274-2401. If I wanted to annoy someone, I would tell them the last 4 digits of my phone number were 7 to the 4th power. That way, if they wanted to call me, they had to work for it. I know, a little odd. That's all right. Okay, to solve a logarithmic equation, we're going to switch to exponential form. Okay, so log of x equals 4. Now, we know that this actually says log base 10 of x equals 4. We know that since no base is written, it's assumed to be 10. And we know that this means the base is 10, the log is the exponent, so 4 is the exponent to get x. Oh, well, we've already had 10 to the 4th today. And so we know that x equals 10,000. If you want to check it, log of 10,000. And enter. That's right, it's 4. So let's try that again. All right, so follow along. All right, the base is 5. The log is equal to the exponent, so 3 is our exponent to get x. 5 to the power of 3 equals x. Oh, we've already had that one also. X must be 125. Let's do it again. 2 is the base of the logarithm. 2 is the base of the exponential. The log is the exponent, so the log is equal to 6. 6 is our exponent. To get 5x, well, 2 to the 6th power, I'm feeling 64. Let's check it out. Yep, 64 equals 5x. To get x by itself, we can divide both sides by 5, and we find that x equals 64 over 5, which is a fabulous answer. You can leave it like that. But if you wanted to divide 64 by 5, it does give us a nice decimal of 12.8. I would accept either answer. Make sure that's a 4. Mine doesn't look like it, but it is. All right, that's it for logarithms. I forgot the title of this. Let me see. Logarithmic functions. That's it for logarithmic functions. Thanks for listening.